Okay, can everybody hear me? Does it work? Yes? Okay, we're good? Okay, all right. Thanks for coming this morning. So I did change yesterday evening the title of the slides of the presentation a little bit because based on everything that I heard yesterday and some reading that I've done and interviews, there's a lot of interest in a developer perspective. So I'm going to take a little bit more of a developer's perspective on the multi-cloud opportunity for Postgres. Okay, so, okay, all right, this is me. You already heard about that, so we can skip that. I'm not going to spend any time talking about Enterprise DB. There's a number of people from Enterprise DB in the room. If you're curious about what we do and how we do it and who we are, you can ask any of my colleagues who are here. So let me dive into, okay, a little bit the same challenge that we had yesterday. Okay, so let's talk a little bit about how developers work with databases. We all know today developers play a much more significant role in the database selection than in the past. In the past, database selection was often something that came down from corporate architecture. It was predefined. There was a lot less flexibility. Today, many companies have a catalog of possible databases that can be chosen, and we see a lot of situations where developers sort of go rogue and they choose whatever is best for the job that needs to be done. So I looked a little bit at, how do developers make this choice? Obviously, the very first thing that they're going to look for is the capabilities that they want in the database. Capabilities, that means text search, GIS, transactional, do I need to store documents, that kind of stuff. So those would be the key capabilities that I want from my data store. The next thing would be, is the underlying platform innovative? Now you may think, why does that matter? Well, it matters a whole lot. Because the worst thing you can do as a developer or an architect is choose a dying platform. Your application, the work that you're going to invest in for the next couple of years, is going to turn into a zombie. And there's quite a few of those zombies out in corporate land where somebody chose a technology that had no future. Okay, and that's, I think, is very, very important when developers choose a technology, make sure it's innovative and it's going to be around for the long run. And many of us have forgotten that in the past, leading databases will release new versions every 4 to 5 years, right? Postgres does it every year. We're sort of used to that, to the rapid pace of innovation that we take it for granted. But that's not necessarily true. So developers look for innovative things that they can use to do new and fun things and things that move forward. They obviously need to support agile development, right? So that's a given when a developer chooses something. And then vendor lock-in. Vendor lock-in has always been a huge issue and still is a huge issue. We heard it again yesterday when Simon was talking about JSON-B. Again, that remains a big issue, okay? And I think it's something that we all need to absolutely have to keep in mind. And I believe where we are today with Postgres gives us a fantastic opportunity to avoid vendor lock-in without a lot of the drawbacks. And I'll get into that into quite a bit of detail. And then obviously, it has to be fast and manageable. Okay, and we'll talk about that a little bit, why that has changed today in Postgres. Okay, so go forward here. One thing that we all know is open source is eating the world, the software world. Okay, I mean, in this survey, there's 1% of companies who said last year open source is not at all important. I don't know who they are. They're probably not there anymore. Okay. This is the same thing that happened with Linux and Unix 15 years ago. At that point in time, everybody says, oh my God, I'm going to get fired if I get on Linux. Well, today you know that all of those that didn't get on Linux got fired. Okay? Today, a lot of Oracle DBAs will say, oh my God, if I get on Postgres, I'll get fired. Well, maybe it should be exactly the other way around. Okay? get on something innovative and start using open source. And you can see here that, that basically 89% of all companies said open source is important. So going forward here, Postgres. Postgres is extremely popular. We heard that yesterday. We all know it. Okay? MySQL still plays a very large role, but Postgres is really rapidly coming. And what's very important about Postgres, today Postgres is available everywhere. Now, I probably forget a couple of things here. I already looked at it this morning, and I remember that I forgot Alibaba, for example, right? Alibaba runs Postgres in their cloud. But basically, the message here is you can do Postgres everywhere. There's not a single platform that I am aware of where you cannot run Postgres. Okay? That in itself is already a very, very big thing. So remember, when you were a developer and you were concerned about lock-in, you were not only concerned about, do I need to pay money to this vendor, it's also, can I deploy wherever I want? And with Postgres, you can actually do that. There's a lot of commercial databases that still do not encourage you to deploy on Kubernetes today. At Postgres, you can just do it. If you feel the use case is right, do it. Okay? Another key trend, and this is something that's near and dear to my heart. We're talking so much about cloud, and there's no good definition about cloud. People talk about cloud, but they do a lot of arm waving, and nobody really understands what cloud is or isn't. So I went to the website of the US National Institute of Standards, and I'm sure in India you have something comparable. And there you can see, at least in the US standard, that a cloud is something that is on demand, self-service, broad network access, pools its resources, is metered, and is rapidly elastic. Scratch your head and say, hey, why can't I do that in my data center? I have VMware, I have vSphere, I have Ansible, I can do all of that. And most of our customers today do all of that. And they do all of that almost everywhere. Yeah, don't do it on your Mac, don't do it on your Windows workstation, but for the rest, you can do this everywhere. So the whole notion that cloud is something special, that cloud only happens on Amazon or on Azure or something, in my view, is pure nonsense. Okay? Cloud is wherever you want cloud to be. Cloud is wherever you do a contemporary advanced deployment. Okay? And I think that's a very, very important thing because there's no reason why you cannot do this wherever you want to. 5 years ago, this would have been a very difficult proposition. Today, Ansible, Terraform, by the way, is just easy. If you want to, for free, you can go to the EDB website, to our GitHub page, and you can download for free scripts that will allow you to set up a highly available Postgres cluster with monitoring in about 20 minutes on AWS or on vSphere. The scripts are there. Look at them, copy them, do whatever you want to with them. They're under Postgres license. So cloud is everywhere. Cloud is wherever you want to deploy. There's no excuse anymore. Now let's talk about vendor lock-in. I said Postgres is available everywhere. What's really interesting, it's available everywhere from, well, no vendor, like you can just take it. You can self-support it. You can ask Second Quadrant, you can ask anybody to support it, right? So you have database as a service that's being offered, including then, add Alibaba to this list. You can self-support it anywhere, right? If you decide, yeah, I don't like RDS Postgres, you can just deploy Postgres on their infrastructure as a service. And then you can say, yeah, self-support it, or I'm going to go to one of the Postgres integrators, or you can come to Enterprise DB and say, support it for me. The really important message is it runs anywhere, and you're in control of which vendor you use. So Postgres gives you a fantastic platform to deploy anywhere and not suffer vendor lock-in. You are in control with Postgres. And that's a very, very important message because now that allows you to do something that you could not do before. Before, you would not use the capabilities of the database. You wouldn't dive into DB2 or Oracle or SQL Server. You would stay away from a lot of their built-in capabilities. You would stay away from a lot of the things that you paid money for, because the moment you dove in, you were locked in into the platforms that they supported and into the cost of their support. With Postgres, that's no longer true. Okay, multi-cloud. Over 50% of our customers tell us today, and this is a survey from ScaleGrid, all the links are there, you can just use, click on them. This is already on the website, I think. Most customers today use more than one cloud. And you may say, well, is that really true? Well, yes, it is. Almost everybody is using OpenShift today and a little bit of RDS, and they deploy something on AWS. And if you look a little deeper, you'll see that they also deploy something on Google. So multi-cloud is absolutely real, okay? So the first thing is cloud is everywhere. You can make a cloud everywhere, okay? And then almost every company uses more than one of those clouds for their deployment. So customers are asking us, be cloud agnostic. They come to us, and this is two very real cases of extremely large North American companies that are saying, do not build anything that ties me into one cloud. Do not make assumption that we will deploy on vSphere or on AWS or on Google. Make it cloud agnostic so that I remain in control. I want to deploy wherever I want, and I want to be able to deploy on multiple places. I want to have the ability to have my read replica, my backup somewhere else. Me, the customer, I want to be in control. Do not lock me in again, okay? And they want to be able to move workloads. Now, not like right now, but they want to have the ability to say, oh, Google, you're not treating me well. I'm going to go to Amazon, right? Or Amazon, you're raising your prices. You can't do that. I'm going to Azure, right? Or say, I have new regulatory compliance. I'm going to go from the public cloud to my private cloud. They want to remain in control. So there's another thing here that happened in Postgres. Today, with Postgres, we have the right tooling that is just like Oracle Enterprise Manager. We at EDB have Postgres Enterprise Manager, and there are many other tools around that allow us to manage Postgres at scale. That used to be a big problem, that you could do a couple of Postgres databases, but could you actually handle 100, 1,000 or more and be reliable? Could you have a single pane of glass into a very large Postgres estate? Could you do management by exception, which is absolutely required when you have a larger Postgres estate? Well, that used to be a problem. It is not a problem anymore. The right management tools exist for monitoring, management, visibility, high availability. There are now block-level incremental backup tools. And you do need block-level incremental backup as soon as you cross about the 1 terabyte, 2 terabyte threshold, because then the database becomes so big that it's very hard to spool it off-site every night. And you have to do that in order to maintain your RPO and RTO requirements. But all of that is feasible now. Okay? So we now have ways to integrate with Oracle and SQL Server, to replicate. We can do change data capture. All the things that we've known from the commercial environments are now available. There's not a reason anymore not to do this. Performance. And few of us are aware enough. Kuntal, where's Kuntal? Kuntal is in the room. Kuntal Ghosh did this this benchmark. He should be, I thought he was here. He did this benchmark. It's available on our website with all the details, and you can also get the code. But the really interesting part about this, let me see if this, I can't make this work. The really interesting part about this is if you look at the curve for Postgres 9.5. Postgres 9.5, 4 years ago, okay? 4 years ago, it peaked out at about 28,000 TPS on a PG bench test. Today, it peaks out at 42,000 TPS. That is 50% faster in 4 years. Okay, that's one thing. And the second thing is the dreaded, what I call the knee, where performance dropped if you give it too many connections, has also disappeared. I'm sure that if we pushed the connections further, we would somewhere see the knee happen out here, right? But it's no longer where it used to be, where you had to exactly get it right in order to get the maximum performance. So think about it. We now have the management tools to manage at scale, and the performance has drastically changed. There's no saying where we will be in another 4 years, okay? So a lot of the reasons why in the past you had to buy into proprietary systems have gone away. From a performance and manageability point of view, we've achieved something where, a lot more people can buy into Postgres now. And then, Gartner Magic Quadrant is a documentation of the fact that Postgres has achieved real enterprise maturity. It's not just me saying it here. You have people like Gartner who I think are very well respected in most companies who are saying today that Postgres is absolutely real and has both the completeness of vision, which basically means all the tools, and the ability to execute, which means the TPS and the reliability to be used in the enterprise. And Postgres, EDB Postgres, has been in the Gartner Magic Quadrant since they restarted in 2013. Now I'm going to ask the audience one question. There's something missing in this graph. What is missing? Postgres, Enterprise DB, Postgres is there. It's Postgres. For all intents and purposes, same engine, same performance, same everything. It's just this also has Oracle compatibility. And Gartner only works with vendors, not with open source groups. So that's why they say that. So what else is missing? Right. And they used to be in there. If you paged back in there, you would find them. They're gone. Okay? So today, Postgres is the only open source relational database left in the Gartner Magic Quadrant. Okay, so I want you to all remember that. If your company goes open source, which everybody is going, that is the platform to go to. And everybody can have these slides, so I think they're going to be on the website and use them. Okay. So Agile is everywhere, right? I mean, is there anybody here in this room who says, "Oh no, my company is not going Agile"? Anybody still here? Anybody still saying, "Okay, no, we're doing waterfall"? And Agile is everywhere. Everybody needs to be able to support that. And then I think the really biggest change that has happened slowly is that developers drive a lot more decisions. They don't drive all the decisions, but they're very, very impactful because developers are all about achieving speed. Time to market. Time to market is really what, I don't know how this thing works. Developers are all about getting stuff done fast, okay? And so developers play a much, much bigger role in the decision making than they've ever done before. So if we recap a little bit, how developers used to take decisions. As I said before, they looked at do I get the capabilities? That's obviously like the very first thing. Can this database do what I need it to do? Text search, GIS, etc. Is it innovative enough, right? Can I build on this, and can I know that my app is going to survive for the next 4 or 5 years, right? I mean, nobody's going to build on Microsoft Access anymore today, right? Because it's going down the hill. Nobody, I think, is going to build a new app today on MySQL, okay? Because again, it's not innovative. There's not a whole lot of drive behind it. Does it support agile development? Does it avoid vendor lock-in, right? And then, obviously, do I get the performance that I need and the manageability that I need? If I say, so what does that mean? Well, in the old ways, there was a significant disadvantage. Because if you try to stay at that level of isolation where you do not buy into the database capabilities, there's 3 things that happen. First, you do not use and leverage the features of the database. So you don't use JSON-B. You don't use GIS. You don't use a range data type. In Oracle, you don't buy deeply into spatial or into XML. You don't do it because the moment you do it, you have committed to the vendor. Now, the problem is, if you don't do that, then you have to write all your own code, okay? If somebody's worked in Postgres with the range data type, for example, it's a fantastic data type. If you do, I don't know, a hotel reservation system or any kind of resource reservation system, the range data type is a fantastic thing. It'll reduce pages and pages of custom code to 1 or 2 lines of queries. It's fantastic, okay? So the trade-off between staying at the SQL level and buying into the concepts is that you write a lot more code. So it takes a lot longer, and your app is actually more fragile. And the worst thing is, you already paid for that code that somebody else wrote, but you're just going to write it again to maintain that independence. And the big thing about Postgres is because Postgres is available everywhere, and from so many different vendors, and also self-supported, you don't have to do that anymore, okay? You can accept and leverage more of the stuff that's already there. So you can avoid your application code growing so much, okay? But there's something that's even more fundamental. It's a little hard to understand, but I'm not sure. Is Oleg in the room? Oleg's in the room, okay. Anybody who has not gotten this little booklet from Oleg? If Oleg has more booklets, go get them. Because in the back of this booklet, so it's almost at the end, he reemphasizes something that Dimitri Fontaine from Microsoft also emphasized. And Parikshit yesterday said, hey, there's a special discount for this book. Go get the book. If you're a developer working with Postgres, go get this book. Or get this, okay? Because they both make the point that if you move a lot of your logic from the database into the application, you lose something very, very important. Not just do you write code that you don't have to write. You're also moving out of the environment where we have all the ACID compliance, okay? Because in the database, you can work with something called a snapshot, right? So you have all the isolation layers, the isolation levels that Postgres offers, right? Okay? Read committed, read repeatable, and serializable. If you move the code into the app and move the data into the app and then try to do all your work in the app, you've left all of that behind. So not just do you write code that you shouldn't write, you actually jeopardize your integrity of your calculations, okay? So there's really a very, very hard reason why doing more in Postgres is not just cheaper and faster. It actually makes a lot more sense to make sure that you have a consistent app. Okay? So basically, what has changed? As I said, Postgres is available everywhere on all deployment options. On-premise, OpenShift, OpenStack. You can use all kinds of scripting. You can use Helm charts with Kubernetes. You can use operators. You can use Ansible, Chef, Puppet, Salt. Probably a few that I'm forgetting, okay? And then the important thing is it's supported by many vendors. So you are completely free to pick the vendor that you like, okay? And if one vendor doesn't do a good job for you, go to somebody else. So there's no vendor lock-in by going with Postgres. I personally believe it is the most innovative and broadest platform. You can do full text search. Dave Page just published a really nice how-to blog on how to do full text search with Postgres. It's very easy. When I approached him about it, because I heard that Mongo could do it, he looked at me like I had 2 heads and said, you know, it's actually about 4 lines of code. That's how easy it is. Okay, so when you think about capabilities, there's a tremendous amount of capabilities in Postgres. Things that in the past where we would say, oh no, we need to combine Elasticsearch, I need Mongo in there, I'm not sure how I do the GIS. Today I'm saying, no, you can do it all in one place, okay? And you don't have to be afraid of platform lock-in or vendor lock-in. Performance, I think I showed you that the performance and manageability today is absolutely there. We see very, very few cases where somebody has to say, hey, for performance reasons, I must stay with Oracle RAC or something. Yes, it happens, but it's very rare, okay? And then, innovation, I mean, multi-model, extensible, a fantastic community. And if you have any doubt about how fast Postgres is evolving and will evolve, take a look at Bruce Mongen gave a great talk about, why Postgres will never die. He really looked at the mechanics of that, and again, understanding that it's a vibrant community and how fast it innovates is again something that you should be aware of when you commit to Postgres. Okay? So let's just look at the old model. In the old model, our layer of insulation or abstraction was between the application and the database. That's where we used Hibernate, Spring, any kind of ORB. That's where we had the JDBC layer, and we really did not want to dive deeper, right? Because the moment we dove deeper, then we committed. We were committed for life of the application, to SQL Server, to Oracle, to DB2, to whatever, right? Okay? And with that came a commitment to money, a commitment to where we could deploy, a commitment to a licensing model, a commitment to so many things that we actually don't want to deal with anymore. So we stayed at that higher level, but by staying at that higher level, we actually did not take advantage of the tool that we actually had, right? Okay? And we moved a tremendous amount of business logic into the application layer. Okay? What we can do now is a bit more interesting. The new abstraction layer is above the cloud infrastructure. Okay? You can now use the database to the hilt. Use the extensible data model. Use the things that Mike Stonebreaker brought to bear over 25 years ago. They are fantastic tools. Use them, okay? And again, Dimitri Fontaine in his book gives great examples of how much power in terms of reduced code and faster time to market and greater consistency you can get by doing that, okay? Leverage the database, and please, I'm a database guy. You should be aware of what these isolation layers are and how dangerous it is if you say, oh no, I'm going to read all of this table in memory, all of this table in memory, and then I do all my stuff here. You know what happened when you do this? If something changed in the database, maybe the seat that you're trying to book is gone. Okay? So now you're committing a seat that has long gone. If you did all that calculation inside the database, you would use the database snapshot and the isolation layer to make sure that you don't sell a seat that's gone. If you do it up here, I know what developers say. They'll say, oh yeah, but before I commit that, I'll verify that it's still available. Okay? So they wrote probably this much code to get the data into memory. Then they wrote again this much code to make sure that they wouldn't commit a seat that is gone. And they could have written 2 lines of SQL query. And they could be to market like weeks faster. Do that, okay? And then, leverage the data types. I think they're great. They're just, there's things like an IPv6 data type where you can just say, is this address in my sitter range? Okay? And it's 1 line. It's 1 line. Try to do that in Java. Okay, you can, but it's not 1 line, believe me, or it's a long line. Okay, now you can move the abstraction layer down the stack. Stay away from cloud vendor specific features because the moment you do that, you have committed again, okay? And then I encourage you to write a lot less code and get to market faster. And really the key message is use one powerful API. Use the Postgres API. I mean, there's a good reason why that is now available in Cockroach and Yugabyte and in other places, because it is a really powerful and very, very portable API. So my final message here, if I can convince this to go, is use Postgres, get stuff done, okay? So thank you very much. Any questions? Oops.
Just a slide before.
This one?
Yep. So there was an amazing statement you said that Postgres is available with every cloud vendor. Effectively, that means that red block is actually part of the blue.
Excuse me?
When you say that PostgreSQL database is available as part of every cloud vendor,
Yeah.
effectively that means that second block, which we've written database, is part of the blue.
No, it's because it's not locked in. You can get that from nobody support it, me support it, second Quadrant support it, Crunchy support it.
That's
Everybody
right.
can do that.
When I go to Azure, I go to Google, I go to AWS,
Absolutely.
whosoever. They're all there.
They're all there.
Yeah. So they provide the interface. Point number 2. The real game that's happening is actually the value-added services. So if I go to AWS guys, they say, here is my sentiment API, which is having an SQL integration. So you can write it straight out of those 2 lines of code, just like you mentioned 2 lines of code, they also mentioned 2 lines of code.
Absolutely.
Now I'm stuck there.
Yes, if you do that, you're stuck again. Absolutely. As soon as you go to proprietary, VMware functions, Azure functions, AWS function, Google functions, Alibaba functions, Nutanix functions, yes, you've committed again. All I'm saying is that the level where the commitment happens has moved down. There's more functionality that's available for you to safely use and still be able to move. Okay?
Can you go back previous slide?
This one?
Just one more before. So this is providing the document-oriented capabilities.
Yes.
When you say document-oriented means the file in which you can perform the text search.
Or Mongo document style capabilities. So JSON-B basically is what I'm referring to, yes.
And in GIS capability, will it provide me the raster analytics part?
The what?
Raster analytics, image processing capabilities. Raster analytics.
Raster analytics. For PostGIS, yes.
Yeah.
That does raster analytics, yes.
Because on site, I was not able to find it out. Can you put some light, what are the capabilities which in raster analytics?
Let's talk afterwards, okay?
Sure.
I'll give you my card and we can connect
Right.
about that, yes. But there's really, I mean, as far as GIS goes, we have done some migrations with customers where they came from spatial to GIS. And initially the customer said, okay, so what did you guys just do? Because we took pages and pages of code and would reduce that to 1 line because the GIS, post-GIS capabilities are really phenomenal, okay, in terms of simplification and compute power, just because GIS is an extensible data type. Okay.
Thank you.
In the previous slides, I think you have mentioned where, so we are using SQL Server as well and Vertica, so we want to migrate to Postgres. So you have mentioned there are tools available for migration for SQL Server, right? Yeah, so is there anything available in the open source?
Sorry, I didn't.
The migration tools.
Yes.
From SQL Server to Postgres.
Yes, so there are tools that help you get the schema across, the data across, right? The schema for tables, etc. And then data, you can do snapshot migrations. There's a bunch of tools that do that. You can do change data capture migrations. We have a tool that does that called Replication Server. HBR supports that. I think Attunity supports that. So there's a bunch of ways of doing it. You may ask me, okay, why do I worry about the difference between snapshot migration and change data capture? The challenge is that a snapshot migration can take a long time, right? So, and often migrations are limited by allowable downtime. So if you tell me I have 12 hours of allowable downtime and I have 500 gigs of data, I'll say, yeah, that's not a problem. We'll dump it and reload it, right? So we'll do a consistent snapshot and reload it. We have this system shut down, so we have a consistent snapshot. We'll recreate it on this side and we're consistent again. We're good to go. 12 hours is a long downtime. 500 gigabytes is actually a small database, right? If you come to me and say, I got 5 terabytes of data and I have 12 hours of downtime, I'll say, well, you can't do that in a snapshot. So what we're now going to look at is maybe we can actually break the snapshot up and do it in parallel. But even there, 12 hours for 5 terabytes, that's not a lot of time. So what we would do is do change data capture, right? We would do a transition once, we record the snapshot on the side, and any change that happens afterwards, we trickle across, okay? Now, the thing that does not exist to my knowledge is a migration for TSQL code, right? So the procedural code inside SQL Server, I am not aware of a tool that translates that. If you're interested, your best bet might maybe iSpirer. They have a translation tool that is kind of interesting, but I cannot tell you how good it is.
You spoke about databases on Kubernetes. So do you see a trend where people are using Postgres on Kubernetes? The reason I'm asking is like some people say it's not recommended and some people I've seen do run.
Good
So
question. Really
what are
good
the use
question.
cases, best
Very
practices?
good question. So just yesterday, my colleague Vibor Kumar has published a blog together with our product manager for Kubernetes. So you'll find it at enterprisedb.com. And the summary of this is basically this. If your database is actually a micro data service, yes, Kubernetes is great. But if your database is a 5 terabyte or 50 terabyte monstrosity, right? Then Kubernetes, you can do it with Kubernetes, but you don't have advantage of Kubernetes, right? So basically, the limit that where we would give guidance is the moment you need to pin CPU, memory, or I/O to the database, at that point in time, Kubernetes really doesn't give you an advantage anymore. It's actually a disadvantage, okay? So if you have a small database that is not dependent on having assigned memory, CPU, or I/O, Kubernetes is great, okay? If you support developers or functional verification testing, Kubernetes is great. But as soon as you need to say, okay, I'm going to start worrying about I/O, like I need to say dirty buffer flushing, right? How it happens, which is a VM setting, okay? Can't do it at the I/O, at the container level, right? As soon as you need to do that, you're sort of getting into this gray zone where you're making the Kubernetes technology do something that it really wasn't designed for, okay? So there's not a hard line that I can tell you, but you go from, yeah, it's very, very good to, well, less good, and then over here it's like really bad. Like I always say in the pets versus cattle analogy, right? You sort of get to the middle, and now your cow has a name, right? And it's not really cattle anymore, right? It gets to be more like a pet. You treat it special. It has a special place in the barn, etc. So it almost becomes, again, like a VMware system with its special settings, okay? So it's a gray zone in between. But if you can go to microdata services, truly microdata services that are fungible and can be stopped and started and are not critically dependent on resources, then it's great. But if you need to assign 100% of CPU, if you need to assign the typical 1/3 of memory to shared buffers, etc., Kubernetes is not going to buy you anything.
Hi. We spoke a lot about vendor lock-ins. Right now, if I have to do a if I have to do a HA in Postgres, I'll have to use Petroni. If I have to do horizontal scaling, I'll have to use Citus. So is there something that the Postgres community is looking forward in terms of getting all this in the core? Like tomorrow, if I want to do horizontal scaling, I want to do it in Postgres core itself and not depend on a Citus or a Petroni.
Yeah, so first, so yes, okay? There is work going on using foreign data wrappers, right, which is very somewhat conceptually similar to how Citus does it. You know, Oleg and his team are also investing heavily in that work to use foreign data wrappers to be able to delegate work. There's still some things missing in Postgres, like parallel execution on queries inside a table or on the shards, okay? So that's gonna come, but I can't tell you when. That's the first thing. Second thing is, we've had a number of customers come to us and ask that same question. I need to do sharding, et cetera. Upon closer inspection, we have never come across an example where it was actually needed, okay? Very often, it's like not thinking about it the right way, okay? And when we're back to the discussion that we just had about microservices, right? If we have a system that has, let's say, customers in India and customers in Singapore, well, do they actually need to be shards of the same database, or could they be two microservices that share a common definition of data that is replicated, logically replicated? Now you have two separate systems. You don't worry anymore about a distributed snapshot, which is what's going to kill you from a performance perspective, right? You don't do that anymore. You just make sure that they use a common product definition, and for the rest, it's two different databases. They feed one common data warehouse, but for the rest, it's two microservices. So I would really, before you go down that path, with all the complexities of a distributed snapshot, I would highly encourage you to think, hey, can't I do something similar by going a smart way with microservices?
That's the last of the question, guys.
So you talked about the issue that we could face when we run Postgres in Kubernetes. So all of these issues, to resolve all of these issues, there's a new wave called NewSQL, right? So there's been some development in NewSQL. New databases are coming, like CockroachDB, which use Postgres protocol. So what do you think about that? Like, should Postgres also move to NewSQL idea? I mean,
I am somewhat skeptical, okay, but maybe I'm a dyed-in-the-wool, ACID kind of compliant guy. And I think Cockroach and its hardware equivalent Spanner are very interesting architectures, right? But you're still trying to stretch the CAP theorem of saying consistency, availability, and can't remember what P stands for. They are hard constraints, right? And Cockroach tries to have has an algorithm to figure out what event actually happened earlier. And I really can't tell you how that will perform, in a truly distributed way. I would really encourage folks who have that problem, again, to think, can I segregate my data? If I have a natural shard, make a microservice. Because you're trying to spread something that by its very nature is a bit fragile, right? So I don't want to say anything negative about Cockroach. I love that they're using the Postgres protocol, and again, it allows you to do everything that I talked about here. And by the way, their Postgres protocol is pretty good. They support PostGIS and a bunch of other things. So again, there's programmed to that API, and if it turns out that you need something that only Cockroach offers, go for it.
but then they promise ACID transactions, like.
Yeah, I am not sure how they can promise that and have the constraints of the CAP theorem. Maybe there's a wormhole somewhere that kind of makes it work really fast. I don't know. So I am aware of it, but we really have not done an in-depth evaluation, and I don't want to say anything negative about somebody else.
Marc is here for, I guess, some time now. So if you guys have any questions, I'm sure he'll be happy to take that outside and after this session. So thank you. Thanks. Marc, for that session.